I made a website where you can control guitar effects by making guitar faces and moving your mouth, and it is a lot of fun. This video will be a general overview of how I made the website and how you can get started making something similar on your own. I won't be going through all the code here, so if you're interested in seeing the whole project, I'll have the GitHub repository linked in the description. For this project, I just used vanilla JavaScript, HTML, and CSS, so if you are familiar with those, you should be good to go for this video. So this is the website here. It is pretty simple. As you can see, my face is being tracked when I move, and importantly, my mouth is being tracked. And there are 3 different effects here that you can switch between, and those are all controlled by the height of my mouth. So depending on how open or closed my mouth is, the volume will go up or down. It controls the wah effect and the pitch shifting as well, and we'll get into that more in a little bit. But here are some examples of me playing around with it with a guitar. If you'd like to see me mess around with this more before watching this video, you can also check out my video on my other channel where I just played some guitar with the website as well. So this idea was in part inspired by stumbling upon the ml5.js library, which is a really cool machine learning library for web. It makes it really easy to integrate different things into your web projects, and one of the APIs they have is a face tracking API, and that is the one I'm using for this project. This library integrates really easily with p5.js if you're familiar with that, but it also works well with HTML5 canvas, and that is what I decided to use for this project because I didn't really need other things P5 offered, and they also had an example for HTML5 canvas, so it was really easy to get that initial face tracking going. So my idea was to use their base face tracking code to draw the outlines and then measure the height of the mouth of the person, and then use that to somehow modify guitar effects. So this code here is responsible for drawing the video onto a canvas element and also doing the face tracking and drawing the parts of the user's face on the canvas over the video as well. So when the website loads, we start face tracking and call this function start face tracking here. And the first thing we do is create a video element in the DOM and then create a webcam capture as well so that we can actually record from the user's webcam. Then we retrieve the canvas element that is already in the DOM, and then we start actually face tracking using the ml5 face API. So once the face tracking model has loaded, we end up in this function here, model ready, which actually starts the tracking of the person's face, and we'll call got results every time it has a new face tracking result. So in got results, we actually draw to the canvas. So the canvas is the visual element you're seeing on the web page where the person is and where their face is being tracked. The video from the video element from the webcam is actually being drawn to the canvas here instead of being shown in the video element. And there are probably more efficient ways of doing this. I just copied this from their example code, but I think they did that because they wanted to draw directly on top of the video in an easy way, so I just went with that here as well. So after the video is drawn to the canvas, as you can see here, if there are any faces detected, then we draw a box around the detection. We draw landmarks, which are the nose, eyes, eyebrows, mouth, any facial features. And then there's also a function to modify active guitar effects based on the detection, but we'll get into that part later. All right, so with that code, we have an important part of the project done already, the face tracking and seeing the person's face on the website being tracked. It's kind of crazy that these libraries exist to make it so easy to do this on web. So from there, what I wanted to do was take a calculated height of the user's mouth based on the features that are drawn to the canvas and use that height to control different guitar effects. But before I could do that, I needed to figure out a way to build something that could play back guitar through web and also add different guitar effects. And to do that, you can use the Web Audio API. The Web Audio API is a pretty powerful system that allows you to take an audio input and change it through different effects and control volume and different parameters. You can do a lot with it through different effects nodes, and then you can play it back through an output. If you're familiar with guitar pedal boards, you can kind of think of the Web Audio API like that. So with a guitar pedal board, you'd have your guitar as the input, and then you connect your guitar to the first pedal. That pedal will be connected to another pedal, a pedal to another pedal, and so on, until you connect the last pedal to your output, which would be an amp. So within the Web Audio API, you would have your audio context, and then within your audio context, you would have your input device, which could be a microphone or an audio interface, and then you would connect that input to a bunch of different nodes to change the input, add effects, change the volume, pan it, things like that. And then your last node you would connect to the output, which could be your computer speakers. So you'd have a chain looking like input, effects node, effects node, effects node, destination. So starting out in my code here, we create an audio context, and this is used for every operation within the Web Audio API. I tried to set this latency hint parameter here to make the audio as low latency as possible. I'm not sure if it's really doing anything. There are some latency problems on Windows because of how Windows handles audio and audio driver stuff, but I tried it anyway. One thing to note about the audio context is that you can only start it on user input, so like the user clicking on the page or something like that. So you might want to have some code like this that resumes the audio context when the user clicks on the page or does some action. So the entry point into the audio code in my program is this startup function here, and that does a few different things. It calls set input devices, initial audio node setup, and then setup audio context. So let me explain those a little bit now. Set input devices retrieves all available audio input devices that a user has connected to their computer that are available for input. So you could have a microphone, a webcam, a interface all connected, and this will retrieve all of those and add them all as options in the input device dropdown on the website so that you can choose the correct one that you want to play back your guitar through. The initial audio node setup function does some one-time setup of a few of the different audio nodes, like the one I use for pitch shifting, and also the one I use to make the guitar sound more realistic, have a little bit of reverb. And these are only to be done one time, so we do it here as part of a setup function. And then the setup audio context function here is probably the most important function. It actually connects everything together into that effects chain we mentioned with the input, and then any effects nodes, and then the output. This function is called whenever the input source or the active effect changes from like volume, wah, or pitch. So it needs to be able to be called multiple times. And that is why there's this disconnect effects function here. We need to kind of destroy the previous audio node chain before making a new one. So once we do that, we call getMic, which gets the actual input source. This function retrieves the actual media stream for the selected input device in the dropdown, and based on the name of the device, I'm applying some different noise suppression things here, like echo cancellation, auto gain control, noise suppression, and otherwise you could have some harsh audio feedback, but if the user is using an interface, I don't want this to be applied because it makes the guitar sound really weird, and ideally they should be using an interface for this. It sounds a lot better with an interface. I didn't even really test it with a microphone, so yeah, this is just kind of a worst case scenario. If they're using a mic, we should apply these, but in the best case scenario, they shouldn't be, and this won't be applied. So then back in setup audio context here, we can now create a media stream source on the audio context with that media stream. And this will be our input, which you can think of as the guitar audio for our guitar effects chain. I'm setting the buffer size really low here to try to reduce latency I'm not sure if that will work well on every computer or not, but it works okay for mine. And then we just reset any effects that have changed from their default value, since this is supposed to be setting up the audio context in a clean state with nothing changed from its initial state. So resetting any pitch changes, any volume changes, and so on. I have a global variable effects, which is an array of web audio nodes that should be connected anytime the audio context is set up, and that starts out as empty. But down in the setup audio context function, we push in any effects that are currently enabled into that list, and then we connect them all in the effects chain. So these nodes I've already set up at the top of the file. They're just global because I don't want to set them up every time the context is reset. So back in setup audio context, we just push all of the effects that we want on the current effects chain in their proper order into that effects list. And then we call connect effects here, which actually connects all of the active effects together to that input stream source and then to the output. So again, this kind of works like a guitar pedal board would. You first connect the guitar audio to the first node, and then for every other node, you just connect them in order in a chain until you get to the last one, and that last one gets connected to the audio context at destination, which allows you to play back your guitar through your speakers. If you wanted to really simplify things, you could just connect your guitar audio source directly to the audio context at destination, and that would just give you your clean guitar signal played back through your speakers. So now let me just talk briefly about how each of the different effects nodes works, how they're set up, and then we'll talk about how this is all hooked up to the mouth moving to control the effects. So regardless of which effect the user chooses, whether it's volume, wah, or pitch, there are some nodes I'm connecting in every case. One of those is the splitter node, which just makes sure that the audio is playing back through both left and right channels. Then we also have the Convolver node, which is created just with audio context.createConvolver, and that makes the guitar sound a bit more like it's being played through an actual amp using an impulse response file. This is a bit of a tangent, but an impulse response is kind of like a snapshot of how an amp would sound in a room, and you can use that to color your guitar tone to make it sound more realistic. I'll link some more information on this in the description if you'd like to learn more. I still need to learn more about this myself, but all you need to know is that this node is just making the guitar sound a bit better. We also just have a makeup gain node, and that is pretty self-explanatory. You can just do audio context.create gain and then set the gain value to boost the volume of your signal. That's necessary because the Convolver node reduces the volume of the guitar a bit. Then we have an Overdrive node, which adds some distortion to the guitar, and that is created in this function here, create overdrive. It uses a wave shaper node, and then you add a curve to that wave shaper node that actually adds the distortion. And I don't know too much about the actual math behind this. Interestingly, there aren't very many known distortion curves that I could find online. I found this one in the developer docs on mozilla.org, but this is pretty much the only one I could find. There aren't very many examples of this. It might be kind of a proprietary thing that guitar amp sim people have kind of secretly and don't talk about. But yeah, it works. It adds some distortion, and I don't really know what it's doing. I don't really understand the math here, but if you increase the amount passed in, it increases the distortion, and that works for me. And then finally we have another gain node here, which again just controls the volume, and that is the actual node that will be modified when you're moving your mouth, when you're using the volume effect within the app. And I put it as the last node in the effects chain so that it has total control over the volume, regardless of any effects that are prior to it. And then depending on which effect the user has, whether it's pitch or wah or not, we add the phase vocoder node or the wah-wah node. So if the user has pitch enabled, then we add the phase vocoder node. The phase vocoder node is set up in this initial audio node setup function, which just runs once at the beginning of the program, so we don't do this multiple times. And it is set up using an audio worklet module, and that kind of allows you to create your own custom nodes within the Web Audio API so that you can run your own custom code and have custom effects. Implementing pitch shifting is actually pretty tricky to do well, and there are some known algorithms, but it's not something I wanted to implement myself for this project. But I was able to find an open source implementation of a pitch shifter based on the phase vocoder techniques, which I don't really totally understand, but it's a way of doing pitch shifting. So I used this open source phase vocoder implementation and added it as a module to the audio context audio worklet here to enable pitch shifting. And then finally, if the user has wah enabled, I add the wah-wah node to the chain. The wah-wah effect comes from a biquad filter node, which you can create using audio context.create biquad filter. You want to set the filter type to bandpass. Basically, this node will boost certain frequencies while cutting other ones, depending on the frequency value that is set. So if you increase the frequency value, it will let more high frequencies through, and if you decrease it, it will let more lower frequencies through, and you can kind of set the width of those frequencies that are boosted through the Q value, and a higher Q value makes it a more narrow range, which makes it kind of a more pronounced effect. And I just set it to 3 because it sounded good to me, but that's something you could totally experiment with. All right, so those are all the effects nodes that are used in this project to make the guitar effects. But how does this all connect back to the face tracking? Well, back in this function here, got results, which if you remember is when we get back face tracking results from the face tracking API, there is this function modify active effects that takes in the face detection. So in this function is where everything comes together. We first get the mouth from the detected face, and then find the height of the mouth. And to do that in this function here, we just look at the highest point and the lowest point on the mouth and just return the difference. The actual numbers here aren't really important. It's more just about the scale from like 0 to 1. But my mouth height range was approximately 15 to 60, so I used those as the default for the min and max mouth heights. But if the current height is bigger than the max default or smaller than the min default, then I reset those min and max mouth heights to make sure that I'm normalizing for the current person who is using the application, not just the size of my mouth. And then here I'm just normalizing that mouth height value to be between 0 and 1 so that we can more easily scale the different effects, so from 0% to 100% engaged. And now finally, based on that scaled value, we can change the currently active effect. So if wah is currently enabled, then we set the wah-wah frequency based on the scale. So in set wah-wah freq, we take in the value, which again is a number between 0 and 1, representing how wide the mouth is currently open. I set the max frequency to 2200 Hertz and the min to 350 Hertz based on a classic wah pedal frequency range. So that means that the value will always be between those two numbers. And then we use a function called lerp to get a number in between that maximum and minimum based on the value, which is again how wide the person's mouth is open. So once we get that new frequency value, we just set the frequency on the wah-wah node, which again is a biquad filter node set to bandpass. And when you set that new frequency, that just emphasizes the frequencies around that Hertz level. So if your mouth is open wider, it will be a bigger number, so higher frequencies will be emphasized. But if your mouth is smaller, then your frequency will be a smaller number and lower frequencies will be emphasized. And this just works like a normal wah pedal would. When you push down on the pedal, it goes up in terms of frequency. If you let go of it, the lower frequencies are emphasized, and that is how this is working here. So then back in the modify active effects function, if volume is actually the active effect, then it is pretty simple. We just set the value of the gain on the gain node, which is at the end of the effects chain, based on the scale of the mouth. And I'm multiplying by 1.5 to make that the max. So the range is from 0 to 1.5, depending on how wide the person's mouth is open. And then if the pitch effect is active, then we set the pitch factor on the phase vocoder node, which allows us to shift the pitch of the current audio signal. The pitch factor is used to scale the audio, and you can actually calculate what that value should be to shift a note any number of steps within the 12-note Western music system with this equation 2 to the s over 12, where s is the amount of steps you want to shift, and if you want to shift down, then s would be negative, and that would give you the value you need to put in for the pitch factor here. And I'm not going to explain the math behind that. If you want to learn more, you can check out an article I have linked in the description that goes way more in depth on this particular thing. But that is just how I got these values for shifting my pitch. So to keep it simple to control with a mouth for this project, I decided just to keep it to 3 different pitches. So down an octave, then not shifted at all, and then up an octave depending on mouth height. So if the scale of the mouth is less than 0.2, so almost closed, then we shift the pitch down an octave by setting the pitch factor to 0.5. If the scale is between 0.2 and 0.6, which is kind of like mid-open, then just keep the pitch the same, don't shift it at all. And then if the scale is greater than 0.6, so the mouth is really wide open, then I scale the pitch up an octave by setting the pitch factor to 2. And then what I'm doing here is just setting the actual value on the pitch factor param, which is coming from the phase vocoder node here. And that actually shifts the pitch of whatever is going through that node in the audio chain. So I think that is pretty much all of the important parts of this project. We have the face tracking code, the actual audio node code, and then the part that combines the two together. Now, obviously I didn't touch on the HTML or CSS that is included in the website, but again, if you're interested in seeing how everything is set up, I'll have the GitHub repository in the description. But yeah, the important parts of this project are all in the JavaScript. I learned a lot about how audio on web works, and it was just a really fun project overall. And I've had some fun messing around with the final results as well. I hope that this is helpful if you're interested in messing around with the web audio API yourself. Maybe if you want to try out some different guitar effects, or maybe if you even want to add a new effect to this project, you could do that. Just copy the code and try it out. There are a lot of different things you could do, and it's really easy to just add in a new node and have it be controlled by the mouth. One thing I should mention is that playback latency with this is pretty variable depending on the platform that you're working on. On Windows, it's pretty bad. You can't really play anything too fast because the latency just makes it really hard, and that's just due to how Windows handles audio on web, and compared to how they handle it within dedicated apps with audio drivers, it just doesn't work very well, and there's been long-standing requests to make this better, but nothing's happened in a lot of years, so it's unlikely to change anytime soon. But in macOS, the latency is actually very good. You could totally play back things in real time, but I was running into some other issues with the pitch shifting not working as well on Macs, and I don't have a Mac myself to really test with. I was on a Windows PC for this project, so it's hard to get everything working perfectly across all platforms with how web audio currently works, I guess, but it's still a fun experiment, and I've had a lot of fun messing around with it, and it's totally fine to play around with on Windows. It just won't be very low latency. Different browsers also seem to handle things differently, like effects sounded different between different browsers, and in theory they should all be the same because they're all implementing the web audio API, but they're not, and it's a bit tricky to get everything working perfectly across all platforms. So I don't know if this would be good for a really serious like consumer project, but for something for fun, it's not a big deal and it's totally fun to mess around with. Also, one more thing, I wish I had used TypeScript for this project. Obviously I could convert it, but I wanted to keep it with vanilla JavaScript because I thought it might be more approachable to share with other people, but I think it would have saved me a bit of time to have TypeScript because it would have made debugging things a lot easier and yeah, errors easier to interpret within my code. So I would recommend using TypeScript if you're doing a similar project. So yeah, this is the first tech video I've ever done. I'm sure I will get the flow down a bit better in the future, but hopefully it was understandable enough. And I'd really appreciate you subscribing to this channel if you are interested in things generally in the space. I'm not sure exactly what I'll be doing. I'll be doing more videos like this, tutorials, projects, maybe things outside of the programming space as well, like in AI, or maybe even looking at like Blender and 3D modeling. I tried to get into that a while ago and didn't really stick with it, but it's a lot of fun. So if you're just interested in any tech things in general, I'd really appreciate it if you subscribed and stuck around for the next videos. I'd really love to see you back here again. Thank you all so much for watching, and I'll see you in the next video.